Okay, we're going to do question 2 from Edexcel A-level paper, Pure Maths 1, June 2018. My name is Sunil Tanna. I'm a tutor and author. My details are on the card, including my phone number and website. And I'm available to do tuitions either in person if you live locally, I live in Buckinghamshire, England, or online if you live further away. Let's have a look at the question. So the question says, curve C has equation y is equal to x squared minus 2x minus 24 times the square root of x, where x has to be greater than 0. And part 1 of the question says find dy dx, the derivative. Part 2, find d squared y dx squared, the second derivative. Part B is to verify that there's a stationary point where x is equal to 4. And part C is to determine the nature of the stationary point, such as a minimum or maximum, and giving a reason for that. Okay, if you look at the formula for y, what you'll see is it's a number of terms involving x. The simplest way to think about that is in terms of powers of x. So we rewrite that formula in terms of powers of x. So we could write it as y is equal to x squared minus 2x to the 1 minus 24. Square root of x is the same as x to the power of half. Okay, we're now ready to do A part 1. So A1, find the derivative dy dx. So what we do, dy dx is equal to, and what we do is we multiply by the index and reduce the power by 1. So x squared becomes 2x to the power of 1. 2x to the 1, or minus 2x to the 1, becomes minus 2 times 1, which is minus 2, x to the power 0. And the last term here, we're going to do a half times minus 24, which gives us minus 12. And reducing the power by 1 will be x to the minus a half. Now we can simplify that slightly, because x to the 1 is just x, so 2x. X to the 0 is just 1, so 2 times 1 is minus 2. And then minus 12x to the minus a half. So part A1 is now complete. Part A2, we need to differentiate again to find the second derivative. We could use the version on this line to make it simpler. So we're going to do 2 times 1, so that will be 2, and then reduce the power by 1 will be x to the 0. This one is 0 times 2, which is of course going to be 0, so we don't really need to think about what the x to the 0 will be, so it just disappears, that term. And minus a half times minus 12 will be plus 6. Then reducing the power by 1 will be minus 3 over 2, minus 1.5. Of course, we can simplify that as well. 2x to the 0 is just 2 times 1. So 2 plus 6, x to the minus 3 over 2. Okay, and that's part A of the question complete. Part B is to verify that there's a stationary point when x is equal to 4. The stationary point is a point where the gradient is 0, or dy dx is equal to 0. So what we're going to do is substitute x equals 4 into this formula here that we have for dy dx. So at x is equal to 4, dy dx will be equal to 2 times 4 minus 2 minus 12 times x to the minus a half. Well, it's minus 12 times... now you could use a calculator to work out what 4 to the minus a half is, but if you're doing A-level maths you really should know that. 4 to the half is the same as the square root of x, so it would be 2, and since it's minus a half, it's 1 over the square root of 2, or divided by 2, so it's 12 times 1 over a half, 2, or 12 times a half. So if you work this out, this is 8 minus 2 minus 6, which of course is 0. So what you can say is at x equals 4, dy dx equals 0, so stationary point. Okay, and we've now completed part B of the question. I'm going to do part C. I'm going to do it on a new page though, so you have plenty of space. Fortunately, I've got another copy of the question, so I don't have to cover up what I've already done. Okay, it says determine the nature of the stationary point, giving a reason for your answer. So to do this, we have to use the second derivative, which we had calculated earlier in part A2. So if I copy that down, the second derivative from part A2 was 2 plus 6x to the minus 3 over 2. So we want to substitute in x equals 4 and determine what the value of the second derivative at this stationary point is. So at x equals 4, the second derivative, d squared y dx squared, is equal to 2 plus 6 times, and we have to work out what 4 to the power of minus 3 over 2 is. Now again, if you have a calculator, you can just type that in. You will have a calculator available for the exam, but if you're doing A-level maths, you should be able to figure that out. So for the purposes of this, let's figure it out. It means 4 to the power minus 3 over 2. Well, 4 to the power minus of a half is the same as 1 over the square root of 4, all right? And we're going to cube that. So it will be 1 over 2 cubed, which will be 1/8. So we've now got 2 plus 6 times 1/8, which is 2 6/8, or 2 3/4. Now, if the second derivative at a stationary point is positive, this tells you it's a minimum. If the second derivative at the stationary point is negative, it will tell you it's a maximum. So in this case, the second derivative is a positive value, so this tells us it's a minimum. So what we would write is it's a minimum because d squared y dx squared is greater than 0. And that's question 2 completed.